Welcome to the live broadcast of the ILS Proton launch of the SES-6 satellite for SES of Luxembourg. SES is a world leader in satellite telecommunications with a fleet of 52 geostationary satellites serving customers across the globe. ILS and Khrunichev have a long history with SES, dating back to the first commercial Proton launch in 1996 with SES's Astra 1F satellite. In over a 17-year time frame, we have launched 21 satellites for SES, well over a third of their operational fleet. We are very proud to be entrusted with launching SES-6 today, our 22nd launch with SES, and our 4th ILS Proton launch so far this year. SES-6 is also the 4th launch of 6 under the multi-launch agreement signed with SES 6 years ago. Based on Astrium's Eurostar 3000 platform, SES-6, weighing over 6 metric tons, will provide coverage over North and Latin America, Europe, and the Atlantic Ocean. The satellite will be located at 40.5 degrees west and will enable the delivery of DTH, data, and mobility services throughout Latin America. I want to express my gratitude to everyone who's worked on the SES-6 mission, including those with SES, Astrium, Khrunichev, and ILS, from mission assignment leading up to today's launch. Whether you're at the launch site watching the broadcast live from the Proton Club at the Baikonur Cosmodrome, or viewing it in Luxembourg, Toulouse, or elsewhere around the world, thank you very much for joining us.
Welcome to today's launch of the SES-6 commercial satellite for satellite operator SES of Luxembourg. This ILS Proton launch is a collaborative effort between ILS, International Launch Services, Khrunichev State Research and Production Space Center, SES, and satellite manufacturer Astrium. The countdown to liftoff continues on launch pad 39 at the Baikonur Cosmodrome in Baikonur, Kazakhstan. Today's launch of SES-6 is scheduled for liftoff at 3:18 p.m. in Baikonur, which is 11:18 a.m. for our customers in Luxembourg and France, and 5:18 a.m. here at the ILS Broadcast Center in Washington, D.C., all on June 3rd, 2013. Thank you for joining us. The countdown to the liftoff of SES-6 begins now. Hello, I'm your host, Jennifer Gladstone. Welcome to today's coverage of the launch of SES-6 aboard an ILS Proton. Allow me to introduce my co-host for today, Karen Young, Mission Manager at International Launch Services. Karen has worked on 8 launch campaigns from Baikonur, and this is her 2nd launch broadcast for ILS. Karen, it's great to have you today.
Hi, Jennifer. It's great to be here with you today. Just a few details about today's launch. Today's launch will be the 386th Proton launch overall since Proton's first flight in 1965 and the 81st ILS Proton launch. It is the 4th Proton launch of 2013, with ILS successfully launching SatMex-8 in March, Anik G1 in April, and Eutelsat 3D on May 14th. This is the 2nd ILS commercial super-synchronous transfer orbit, or SSTO mission. The first SSTO mission was Intelsat 22, successfully launched in March 2012. The satellite operator for today's launch is SES, headquartered in Luxembourg, and this will be the 22nd SES satellite launched aboard an ILS Proton. The satellite manufacturer is Astrium, headquartered in Toulouse, France. This will be the 16th Astrium satellite launched on an ILS Proton.
Karen, thank you. It is our pleasure to welcome Martin Halliwell, Chief Technology Officer at SES, with this greeting recorded earlier at the Baikonur Cosmodrome.
Hello everybody, my name is Martin Halliwell. I'm the Chief Technology Officer of SES, and here we are in sunny Baikonur for the first of 4 launches this year. This is the launch of SES-6. SES-6 is a 6.1-ton satellite, 13 kilowatt payload. It has 43 C-band transponders and 48 Ku-band transponders. It's designed to fly at 40.5 degrees west and will replace our NSS 806 satellite. It has coverage of the Americas, of the Atlantic Ocean, and of Europe. The services it'll provide will be predominantly to support the cable TV network in South America, the DTH, VSAT services, and also the digital inclusion program for the government in South America. I would like to take this opportunity to thank the colleagues from both Astrium and ILS who have made both the satellite and the launch vehicle for us. And most of all, I would like to thank my colleagues of SES and the procurement team who have worked so hard over the last 3 years to make this mission possible. Thank you very much, and go ILS, go Proton, go SES-6.
The ILS Proton mission for the SES-6 satellite will entail 5 Briz-M burns and take 15 hours and 31 minutes from liftoff to injection into geostationary transfer orbit. Let's take a look now at the SES-6 mission profile.
The following is the description of the super-synchronous mission flight profile of the ILS Proton launch vehicle with the SES-6 communication satellite on board. The first 3 stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the Briz-M payload adapter system and the SES-6 satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 61.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels eastward. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then, the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes. And then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition, high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second or 4.5 miles per second relative velocity. The upper stage of the ILS Proton rocket is called the Briz-M and is designed to inject payloads into a wide variety of target orbits. There are 5 Briz-M burns in this SSTO mission design. The first Briz-M burn occurs about 1.5 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This will last long enough to achieve a low Earth circular parking orbit of 173 kilometers. This 4.5-minute burn spans from Siberia to Russia's east coast. 1 revolution later, the second Briz-M burn for the SES-6 mission occurs about 1.5 hours after the first burn main engine cutoff and centers the descending node of the second orbit. The resulting elliptical orbit is called the intermediate orbit. This 19.5-minute burn spans from the southern tip of the Japan Island chain to 600 miles northeast of New Zealand. 2 hours, 14 minutes after the second burn, the third Briz-M burn starts. Soon after this burn shuts down, the depleted auxiliary propellant tank is jettisoned, and the fourth Briz-M burn begins. The resulting orbit is called the transfer orbit, where the apogee is greatly increased to supersynchronous altitude of 65,000 kilometers. These 2 burns add up to almost 18 minutes and span from the western side of China to the southeast side of Australia. During the coast phases, the Briz-M performs attitude maneuvers in order for the SES-6 solar arrays to be exposed to the sun at a predetermined solar illumination angle which is designed to satisfy its thermal and power requirements. 10.5 hours later, during the fifth and final Briz-M burn, the orbital unit will perform a large plane change maneuver from 50.5 degrees to 26.3 degrees inclination and increase its perigee to about 4,500 kilometers in a 3.5-minute burn. About 12.3 minutes later, the SES-6 satellite is separated from the Briz-M to reach its targeted supersynchronous transfer orbit. The total mission time from launch to SES-6 spacecraft separation is approximately 15 hours and 30 minutes.
The first burn of the Briz-M upper stage is scheduled for completion about 16 minutes into the flight. Our broadcast will conclude after that burn since the rocket will be out of range of our tracking stations as planned, and we will not receive any updates at that time. And now we are about 7.5 minutes away from launch of SES-6. And in the meantime, Astrium CEO Eric Behringer joins us now with this message on behalf of the satellite manufacturer.
As the old saying goes, quality is when the customer comes back to see you and not when the product comes back. Quality is essential in space, and I would like to thank SES for the trust they have shown in the quality of the telecommunication satellites of Astrium. SES is already operating 5 Astrium-built Eurostar satellites. Between 2009 and 2010, SES ordered a batch of 5 Astrium E3000 satellites. And today, it's with great pleasure that Astrium is delivering the second satellite from this batch, SES-6. I would like to thank SES for the confidence they have shown in us and our products. Looking at this long-term relationship, I feel that we've built mutual respect and focused on the same goal, technical excellence and quality. For this also, I would like to thank SES. In this context, I would like to extend warm thanks to all the Astrium satellite suppliers who contribute to the high quality of our E3000 broadcast satellite. And I would like to congratulate, of course, as well, my Astrium telecommunication team. Great job! Finally, I would like to thank ILS Proton for their professionalism and the care and attention that they have attached to this mission. So, it's with a great deal of emotion that on behalf of all of those who participated in this project, I wish SES-6 a successful launch and a long and successful mission. We want SES-6 to be a top quality product that makes SES come back to us.
And now let's check in with Karen for a check on the current weather in Baikonur. What can you tell us?
The most recent weather readings I've received are cloudy skies. We have a liftoff temperature range of 25 to 27 degrees Celsius or 80 to 84 degrees Fahrenheit. The ground winds are coming from the north at 5 to 8 meters per second. Now the upper level winds are all within limits at all altitudes. So weather conditions in Baikonur are ideal, and currently we are go for launch.
Thank you, Karen. Don Harms, Vice President of Sales, Marketing and Communications at ILS, sends us this message from Baikonur.
Hi, I'm Don Harms, Vice President of Sales, Marketing and Communications for ILS. We are honored to be here today for the SES-6 launch, our 22nd for SES and our 16th with Astrium. I'd like to take this opportunity to thank all the people who have worked so hard over the last couple of years, from Khrushchev, ILS, SES, and Astrium. Thank you so much. Spasiba.
Now let's take a chronological look at SES-6's journey to launch.
Typically, it takes about 2 years for the launch vehicle and satellite to be built, tested, and shipped to the launch site. From crew and spacecraft arrival, it can take from 4 to 7 weeks to complete a launch campaign. Today's launch begins with the early team arrival in Baikonur. The spacecraft arrives aboard an Antonov cargo jet at Yubileyny Airfield. The spacecraft is offloaded from the plane and placed onto a railroad car. The thermally controlled rail car is hooked up to maintain the proper environmental conditions for the spacecraft during their 6-hour trip to the launch processing facilities. Once in the high bay, the spacecraft team does a series of system tests and other standalone operations, including fueling the spacecraft. Fueling of the spacecraft is then completed. The satellite is then mated to the Briz-M upper stage and rotated horizontally to be encapsulated in the payload fairing in Hall 101. The spacecraft, fairing and upper stage are now referred to as the ascent unit. The entire assembly is mated to the booster stages of the ILS Proton launch vehicle in Hall 111. The integrated launch vehicle is rolled to the Briz-M fueling station, where fueling of the Briz-M is completed. The complete rocket rolls out to the launch pad, where the entire vehicle is changed from its horizontal position on the rail car to a vertical position on the launch pad. Then the service tower is moved into position. The mobile service tower provides services and accessibility to the launch vehicle and spacecraft. Proton rollout to the pad always occurs at exactly 6:30 in the morning, corresponding with the precise time the vehicle for Yuri Gagarin rolled out in 1961, marking this landmark anniversary in space advancement.
And now my co-host Karen Young will take us through the final pre-launch preparations and through liftoff of SES-6. Karen?
Jennifer, in addition to those at the launch site, there are many others watching who have played an important role in the SES-6 mission, and we'd like to say thanks for all your hard work in getting to this moment. SES in Luxembourg, Astrium in Toulouse, France, Astrium UK propulsion team, who are from Stevenage in the United Kingdom, Khrunichev in Moscow, ILS headquarters in Reston, Virginia, and of course all the others who have helped make today's launch of SES-6 a reality. Today's launch of the SES-6 satellite on ILS Proton is the result of an accumulation of a lot of hard work and long hours, and everyone on the launch team is eagerly awaiting the liftoff. Teams are in their places in the launch bunker, the control rooms, ground stations and communication centres, and the final go for launch polling we mentioned earlier is being completed. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Ignition starts. We have liftoff of an ILS Proton rocket from pad 39 at the Baikonur Cosmodrome in Kazakhstan with the SES-6 satellite on board. It can be a little difficult to see, but at about 10 seconds after liftoff, the rocket does a roll maneuver and will soon experience maximum dynamic pressure, which is the maximum aerodynamic load on the vehicle. For Proton, it corresponds to about Mach 1.6 and occurs at 1 minute, 2 seconds after liftoff. Everything seems to be proceeding nominally as the vehicle heads across the Cosmodrome vertically in the northeasterly direction with a flight launch azimuth of approximately 61.3 degrees. It's an absolutely glorious day in Baikonur, and the viewing for all the teams on the ground will be absolutely spectacular. They could probably see this as far as the eye can see. We're coming up on the first stage's separation from the second stage that is set to occur at 2 minutes into the flight. Watch for the halo effect as the second stage engines ignite prior to the separation from the first stage. And we have confirmation of a good separation between the first and second stages. I've got it. We have a signal of ignition on all 4 second stage engines. They will burn for a total of about 3 minutes and 27 seconds. The next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27 seconds. 20 seconds after that, the payload fairing pyros will fire, separating 2 halves, and they will be jettisoned from the vehicle.
Thank you, Kieran. As the ILS Proton travels easterly downrange, our viewers are going to notice a lag in our reporting of some key mission milestones. The reason behind this delay is that as ILS Proton follows its pre-programmed flight path, it's going to pass out of range of the Baikonur receiving stations, and the signals will be received at stations downrange and transmitted back to Baikonur, and this may cause those brief delays in reporting. So now there's a short video about SES-6 prepared by satellite manufacturer Astrium. Here's a message from SES Senior Vice President Commercial Americas, Elias Zakak.
Greetings from Baikonur. I'm Elias Zakak, Senior Vice President, Commercial Americas for SES. SES-6 will be the 53rd satellite in our SES fleet. It is designed to replace NSS-806 and to provide additional growth capacity. Its three key missions are: one, to provide and to strengthen our video cable neighborhood throughout Latin America. Two, it is to provide Ku-band capacity for DTH platforms throughout Latin America, especially in Brazil. And three, it is to provide mobility platform services for aeronautical and maritime customers throughout the North Atlantic. I want to thank Astrium and ILS, especially the joint launch team here in Baikonur, who has done an excellent job managing this campaign. Muchas gracias a nuestros clientes en América Latina y obrigado.
We are now about 7.5 minutes into flight and coming up on some important milestones. So, Kieran, what can you confirm for us?
I can confirm that we have successful stage 2-3 separation and payload fairing jettison. The payload fairing jettison occurs at a velocity of about 4,600 meters per second, or 2.9 miles per second at an altitude of 137 kilometers. Our next major milestone happens in about 4 minutes. That will be the separation of Proton's third stage from the Briz-M upper stage.
Right now, Kieran, tell us a little bit about the SES-6 satellite.
Sure, Jennifer. As a multi-purpose satellite, SES-6 consists of both Ku-band and C-band transponders. The satellite is planned to replace NSS-806 at 319.5 degrees east or 40.5 west longitude. This orbital location will allow SES to provide enhanced capacity over North and South America, the Caribbean, Europe and the Atlantic Ocean region. The expanded payload will also support DTH and VSAT platforms in emerging markets. The SES-6 satellite has a launch mass of 6,100 kilograms, a wingspan of about 40 meters once its solar arrays are deployed in orbit, and a spacecraft power of 13 kilowatts at the end of its 15-year design lifetime. Launch and early orbit phase operations will be conducted from the Astrium Spacecraft Control Center in Toulouse.
Kieran, thank you so much. The SES-6 mission team for this ILS Proton launch is made up of representatives from ILS, Khrunichev, SES, and Astrium. Representing ILS is Program Director Bertrand Moncouquet, who sends this greeting from Baikonur.
I'm Bertrand Moncouquet, the ILS Program Director for the SES-6 mission. Welcome in Baikonur, and with a very nice weather, as you can see, and it's very, very hot. This is my 10th launch campaign with ILS, and the second in a row this year. Just 3 weeks ago, we were launching W3D, and now we're ready for SES-6. I want to thank all the teams for a very great job done on this campaign. SES, Astrium, Khrunichev, all subcontractors, and also ILS at Reston for the support. Thank you all. And now, go ILS, go Proton, go Briz-M, go SES-6.
Here now is Gilbert Griseri, Sales Director for Astrium, recorded earlier in Baikonur.
I am Gilbert Griseri, Sales Director at Astrium. I am very pleased to share this very exciting moment with SES, ILS and everyone here in Baikonur. We are proud to deliver on time this high-quality satellite to our customer. SES and Astrium share the same objective of technical excellence, and we always deliver with no compromise on quality. I would like to thank SES, ILS and Astrium teams for all what has been achieved up to now. Let's look at what happens now. Thank you.
So, Karen, what's the current status of the mission?
Well, I'm pleased to announce that we have the Stage 3 shutdown confirmed. We also have the orbital unit separation confirmed. So everything at this point is going nominally.
All right, Karen, thank you so much. The Briz-M upper stage is restartable for mission optimization and is compatible with all major commercial spacecraft platforms for dedicated single and multiple launches. The Briz-M can support dual-use satellites and satellites with hosted payloads, and even has the capability to build and serve space stations. Now let's learn more about Proton's Briz-M technology and its role in the SES-6 mission.
The following is the description of the super-synchronous mission flight profile of the ILS Proton launch vehicle with the SES-6 communication satellite on board. The first 3 stages function to propel the...
All right, well, during the SES-6 launch campaign, photographer Toby Smith, represented by reportage by Getty Images, has been with the VIP group to gather photo material for use in a broader story about satellite construction, transportation, and launch. The photos are to be published by some of the world's leading publications. He focuses on large-scale projects for exhibition, communication, and advocacy. His still and video projects cover global infrastructure and human stories with clients including National Geographic, The New York Times, BBC, Sky, The New Yorker, Sunday Times Magazine, and Time. Toby uses the forefront of technology to capture dramatic images without the need for post-production. He also utilizes modern time-lapse equipment to compress the changing landscape conditions into video form or location lighting to change the aesthetic. Now we continue to track the flight of SES-6 into orbit on an ILS Proton rocket. Karen, bring us up to date on the status.
I am pleased to announce we have the Briz main engine start confirmed. So nominal operations as we progress through this launch.
Very good, thank you. Now let's hear a translated interview with Leonid Borisov, Krunichev Program Director, about today's SES-6 mission.
Hello everyone. I'm a Program Director of Krunichev Space Center, Leonid Borisov. Today, we started the pre-launch processing of SES-6 spacecraft with launch vehicle Proton-M. The spacecraft is manufactured by Astrium for SES. Krunichev Space Center and SES have a long history of cooperation. In 1996, the first launch of Proton-M launch vehicle have injected Astro 1F spacecraft into orbit. This spacecraft is still in use. The SES-6 launch is very important, both for Russian colleagues and foreign partners, since it is the first time that the SES spacecraft is injected into geostationary orbit using solar synchronous orbit, with the height of the apogee of 65,000 kilometers. I would like to wish the successful completion of this campaign to all its participants, as well as to thank everyone for good cooperation.
This is the second Super Synchronous Transfer Orbit, or SSTO, mission for ILS Proton. So, Karen, what is the benefit of this flight design for SES-6 satellite?
Well, to summarize it very briefly, the use of an SSTO flight design provides an orbit with a much higher apogee, or high point over the Earth, than standard GTO missions. On the screen is the flight design for a GTO mission. I won't go deep into the physics of the SSTO flight design, which is what we see now. But in a nutshell, being further away from the large gravity force of the Earth means the spacecraft can use smaller amounts of its precious onboard fuel to trim itself in GSO orbit. The end result is an overall benefit to the customer, which is a longer service lifetime for the satellite due to the extra fuel savings. The SSTO mission profile is just one of the alternative mission design capabilities of Proton, and one of the ways we customize each and every mission to meet the needs of the customer and their business requirements.
Karen, thanks so much. Here's a greeting from the launch site by Dennis Heiler, Launch Program Manager for SES.
Hello, I'm Dennis Heiler, the SES Launch Program Manager for SES-6. Welcome to Baikonur. We're now in our final preps for the launch. And with that, I'd like to say thank you to all the teams involved. It was a fairly much compressed schedule, and Astrium, Khrushchev, ILS, SES all worked together so that we could come to this conclusion and make our schedule. So I'd like to thank all of them. Without them working together, we'd probably be late. So thank you.
ILS Protons can weigh over 705 metric tons, or more than 1.5 million pounds at launch, and are 191 feet tall. But just exactly how fast can it go? Here's a speed comparison that might put it into context for you. Velocity is the distance per unit time that an object travels in a specified direction. Now, we all know the ILS Proton moves at incredible speeds. That's a given. But just how fast is a Proton rocket exactly? At liftoff plus 38 seconds, here's the formula for the answer. 567 miles per hour equals 253 meters per second. Using this formula, the Proton closely matches the velocity of several of the world's fastest commercial jetliners at cruising speed. At liftoff plus 68 seconds, here's how fast the ILS Proton is moving. Mach 2, or twice the speed of sound. At this point in the mission, the Proton matches the velocity of an F-22 Raptor with full afterburners engaged. Finally, at liftoff plus 82 seconds, the ILS Proton is traveling at Mach 3, or 3 times the speed of sound. At this point in the mission, the Proton matches the velocity of an SR-71 Blackbird U.S. reconnaissance jet. We'll leave you with this staggering thought about the velocity of an ILS Proton rocket. At maximum velocity, the Proton travels at 5.9 miles per second. At that velocity, the Proton can travel from San Francisco, California, on the United States West Coast, to New York, New York, on the United States East Coast in 7.3 minutes. As Karen has indicated, through communication with the Baikonur control room, we are at the point in the mission now where the Briz-M upper stage is just getting started. A total of 4 burns will be required before we get to spacecraft separation. So, Karen, what is the current status of the SES-6 mission?
I am happy to confirm that the Briz main engine cutoff is confirmed and that all operations are nominal and we are moving along the flight path as planned. A few minutes from now, the Briz-M will enter a planned blackout period. This is when the vehicle is currently out of range of any designated Russian tracking stations, and we will not be scheduled to be back in communications again until after the second burn is completed, which is about an hour from now.
All right, Karen, thank you so much. Representing satellite manufacturer Astrium on the mission team is Christian Fournier, satellite program manager, recorded earlier at the launch site.
Hello, I'm Christian Fournier, the Program Director for the SES satellites. SES-6 is the second in a series of 5 satellites ordered by SES 3 years ago to Astrium. SES and Astrium teams have developed over the years the same values of rigor, quality and excellence. The launch campaign here in Baikonur went on very smoothly thanks to the professionalism and good spirit of ILS, Khrushchev, SES and Astrium teams. Astrium is proud of the SES-6 satellite, a good example of the capabilities of the Eurostar 3000 platform. With a mass of more than 6 tons and 13 kilowatt power, the spacecraft will provide C and Ku band transponders over more than 8 different coverages. On this particular launch, the Proton flight will last more than 15 hours, and it's only after then that our teams in Toulouse will be able to take control of the spacecraft and drive it to its final destination at the 40.5 degree longitude west.
Khrunichev's State Research and Production Space Center is one of the cornerstones of the global space industry and is the majority shareholder in ILS. With more than 35,000 employees, Khrunichev's varied product lines serve the global satellite industry as well as Russian federal and international space programs. Here's a little more now on Khrunichev.
Khrunichev's State Research and Production Space Center has long been one of the most prominent space industry manufacturers in the world. Today, Khrunichev serves international satellite and space programs as well as Russian federal missions, working with 45 different companies in 22 countries across the globe. Khrunichev's diverse product lines include launch vehicles and launch vehicle upper stages, communication and Earth observation satellites, rocket engines, and space station modules. In 1993, Khrunichev joined forces with Lockheed Corporation and Energia in a joint venture to market Proton to the commercial satellite industry. In May of 2008, Khrunichev became the majority owner of that company, International Launch Services, or ILS. The merging of an American-based company with a Russian space industry giant was an historic first. The strategic consolidation that brought ILS into the Khrunichev fold also included bringing some of the largest Russian space manufacturers under the Khrunichev umbrella. The supply chain consolidation directly supports Khrunichev's most vital strategic asset, the Proton launch vehicle, as well as continued development of the next generation launch vehicle. Khrunichev's commitment to quality is exemplified in the phased improvements to the Proton launch vehicle. All upgrades have been 100% successful in flight. The phased improvements have increased Proton's lift capability to over 6 metric tons. And in 2011, ILS Proton launched its heaviest satellite, Viasat-1. The next phased upgrade will bring the total payload system's mass capability to 6.35 metric tons. And in direct response to operators' demand for lower costs to orbit for small to medium satellite launches, ILS and Khrunichev brought the ILS Proton Duo to the market. Using the full performance of the Proton rocket could reduce orbit-raising time from 6 months to 4 weeks for satellites with electric propulsion. Khrunichev has also invested in infrastructure upgrades, including a second spacecraft processing facility in Baikonur, in full use since 2011. Refurbishments to Launch Pad 39 are now complete, following the upgrades to Pad 24 last year. Khrunichev's commitment includes the development of the next generation of launch vehicles. The Angara launch vehicle system will include a light, medium, and heavy lift variant to cover the entire satellite mass spectrum. The Angara engines will utilize an environmentally friendly liquid oxygen kerosene mixture. Ongoing investment and improvements, our unified quality management system, and our commitment to mission success allows Khrunichev and ILS to provide significant value to customers, and a steady launch tempo provides a backdrop for a sustainable future serving the global space industry.
So, Karen, tell us what has to happen after the Proton flight in order for the satellite to become operational.
Our broadcast takes us through the first Briz-M burn. After the broadcast completes, the Briz-M will execute 4 additional Briz-M burns before separating the spacecraft into a super synchronous transfer orbit at 15 hours and 31 minutes after launch. The ILS Proton will have completed the mission, and SES and their contractors will take over operation of the satellite from that point forward. The spacecraft will then execute a series of planned operations over the next several days, which include solar array deployment, reflector deployment, and a series of apogee engine burns. These burns will bring the orbit inclination down to 0 degrees and raise perigee to match the apogee, resulting in a circular geosynchronous orbit over the equator. Following a period of in-orbit testing, the spacecraft will settle into its operational slot of 40.5 degrees west longitude and begin to provide service to SES's customers.
Remember, you can keep current on the SES-6 mission by visiting the ILS website, ilslaunch.com, by following us on Twitter, or by liking us on Facebook. Also, at ilslaunch.com, you can check out pictures of past ILS Proton launches, as well as the current mission, read blog posts from the ILS mission team, and learn more about ILS and its missions. The next ILS Proton launch is Astra 2E, scheduled for July. I'd like to thank my co-host for today, Kieran Young, Mission Manager at ILS, for her assistance and mission updates today. Kieran, it's great to have you.
Thanks, Jennifer. It was fabulous to co-host today's launch broadcast with you.
And this concludes our live coverage of the ILS Proton Briz-M vehicle launch of the SES-6 satellite. On behalf of the ILS team and our partners and customers worldwide, I'm Jennifer Gladstone. Thank you for watching.